Hello everyone, you are all welcome to lecture number 1253, and today's topic is the methods of preparation of alicyclic compounds and its properties. In previous lectures, I have already discussed the conformation and stereochemistry of alicyclic compounds, and here I am going to give some methods and their chemical properties, how it is going to react with different type of halogens, acids and alkali. And in preparation, actually some name reactions I am going to give, where sometimes it is closure of the open chain into the ring form. So some halides like dibromopropane or dibromopentane in presence of some catalysts like zinc and others can be cyclized into cyclopropane or cyclopentane, and sometimes the hydrogenation of benzene can give you 6-member ring like cyclohexane. Sometimes dicarboxylic salts like sodium salt of dicarboxylic acid, once it is cyclized, heated by elimination of one molecule of water, it will be converted into cyclopentane. So like that, so many reactions I am going to give here to prepare the alicyclic compounds. So here all these methods are given. Some of them are in the form of name reactions. Number one, that is called Freund's method. And this method involves the action of metal on suitable dihalide, that is dibromopropane. When it is treated with zinc, it is converted into cyclopropane, and Zn Br will be out. Number two, Dickmann's method. This method involves Dickmann condensation involving cyclization of suitable aliphatic dicarboxylic ester, and here this is your dicarboxylic ester. It is CO, it is ester, and when it is treated with NaOC2S5 plus ethyl alcohol C2H5OH, and there will be elimination of carbon dioxide gas and it is heated, you will get cyclopentane. Number three, by hydrogenation of aromatic compound, that is benzene, and when the cyclohexane and its many derivatives can be best prepared by the catalytic hydrogenation, and catalyst is nickel of aromatic compounds at high temperature and under pressure. For example, this is aromatic compound benzene at 200 degrees centigrade temperature in presence of nickel as a catalyst. Under pressure, it will be converted into cyclohexane. So now in continuation, number four, from active methylene compound, we can obtain alicyclic compound. The active methylene compounds like malonic ester and acetoester ester condensed with dihalide to form cyclopropane. Reaction is given here. The methylene compound is here, and then ester is there, and when it is treated with C2ONa, it is converted into cyclopropane. Number five, from alkene, means is carbon-carbon double bond alkene, and when it is treated with C2N2, that is diazomethane, highly explosive compound, and when both are heated together, you will get cyclopropane. And number six, from alicyclic compound, alicyclic compound means that is cycloalkanol. We can call it cyclohexanol is a type of aliphatic alcohol, and when it is treated with concentrated sulfuric acid by elimination of one molecule of water, double bond will be there and we will get cyclohexene. That cyclohexene, when it is subjected to bromination, we will get bromo cyclohexane, and from there one molecule of HBr is removed, and then finally we will get cyclohexane. The properties: cyclopropane is a gas, and the boiling point is minus 33 degrees centigrade, and cyclobutane is a liquid which has 12 degrees centigrade boiling point. It is non-polar and it undergoes substitution reaction, also hydrogenation. Those reactions I have already given, and also in presence of ozone it undergoes ozonolysis. So here some of the important reactions of cycloalkane, or we call it alicyclic compounds, are given. So the number one is cycloalkanes undergo a typical free radical substitution reaction. If I say free radical substitution means in presence of either light or temperature, it undergoes free radical substitution reaction. Means first free radical is formed with the help of homolytic bond fission, and that free radical will attack and formation, there will be formation of that is bromocyclopentane. So cycloalkanes undergo a typical free radical substitution reaction when treated with halogens at high temperature or in presence of light. So this is your cyclopropane, and when it is treated with bromine at 300 degrees centigrade, it is converted into bromocyclopentane. And number two, electrophilic addition reaction. Here, why actually the reaction name is given? What type of, on the basis of what type of species is going to attack? So first one was that is free radical substitution. The second one is called electrophilic addition, means electrophile, E positive, H positive, NO positive, any of such which are deficient in electron, when they are attacking, that reaction is called electrophilic addition reaction. So cycloalkanes undergo a typical electrophilic addition reaction across the carbon-carbon double bond. Whenever there is carbon-carbon double bond in the ring of alicyclic compound, it will undergo addition reaction. So here it is cyclopentene, and this cyclopentene, when it is treated with bromine in presence of carbon tetrachloride, it is converted into 1,2-dibromocyclopentane. Number three, hydrogenation. I have already discussed this when we discussed the method of preparation, that cycloalkane or alicyclic compounds, they undergo hydrogenation, means they will consume, or hydrogen will be added, and if there is double bond, it will be converted into single bond, like for example cyclohexene. So here compound undergo catalytic hydrogenation, and that catalyst is nickel, Rani nickel hydrogenation reaction. So this is your methyl cyclohexane, and this methyl cyclohexane, if it undergoes catalytic hydrogenation and Rani nickel, if I say Rani nickel means it is extra pure nickel, because if you are taking ordinary nickel, a reaction will not take place. That's why if I say Rani nickel means it is extra pure nickel. So it will undergo hydrogenation and you will get methyl cyclohexane. Then number four, ozonolysis. It undergoes ozonolysis, means the ozone oxygen will be added. So alicyclic compounds undergo ozonolysis to form carbonylic compound, and that carbonylic compound is called ketopentanol. Why it is ketopentanol? Because 5 carbon is there, and this is your keto group and this is your aldehyde. So it is having both functional group, aldehyde as well as keto group. That's why it is called 6 keto. Means at 6 carbon there is keto group, and then there is aldehyde group. It is called 6 keto pentanol. AL stands for aldehyde, and it is converted in presence of ozone, that is called ozonolysis. So with this I will stop, and now the alicyclic chemistry is over, the full course where I have discussed the stereochemistry, conformational analysis, and also preparation and properties. Once again, thank you very much for watching the lecture.